Hi guys, this is topic one, lesson one again. We've already learned the vocabulary, but now we're going to take a look at what we actually do need to learn here in lesson one. This is actually the first thing that you're going to learn for this school year. So pay close attention to it. You're going to hear me say some of the vocabulary that I said before. Okay, on the board here, you can see that I have two decimals. I have one decimal, 0.7, which is terminating, which means it stops, which is what we learned. And I've got another one, 0.7, repeating, which is a repeating decimal. So our goal here for today is how do we change these into a fraction? What is the equivalent fraction to the vocabulary words that we talked about? So in order to take these to an equivalent fraction, we'll first start off with 0.7. That's how you say it in science class and math. We say 0 and 7/10. So if we say 0 and 7/10, we know that this is the place value for ones, and this is the place value for tenths. So we simply turn this into 0 and 7/10. So our fraction is simple. It's 7/10. Can't get much easier than that. We don't even have to simplify that. Okay, the 7 is a prime number. 10, the only multiples of 10 are 1, 2, 5, or factors of 10 are 1, 2, 5, and 10, and none of those go into 7 because 7 is prime. How do we do this one? Now, 0 and 7/10, remember, is repeating, which means, in essence, that is what is happening. And you'll also see 3 dots over here. That'll also tell you that it's going to continue to go on and on and on. So this is a repeating decimal. So that's obviously not the same fraction as this one. So where some 8th graders get messed up is they think if they see 0 and 7/10 and 0 and 7/10 repeating that it's the same thing. It's not. It's not the same. So how do we change this? Here's how you change it. First, we have to turn this into an equation, which we haven't learned to solve yet this year, but you have in the past. So here's how you turn this into an equation. We're going to make this equal to x. So we're going to say x equals 0 and 7/10 repeating. Now we are going to look at how many repeating digits there are. So repeating digits, as you know, is one of our vocabularies. There is only one repeating digit. That repeating digit is the number 7. So since there's one repeating digit, we are going to use the first power of 10, which is also part of our vocabulary. The first power of 10 is a 10. 10 to the power of 1 is equal to 10. So we are going to multiply both sides of this equation by 10. So if I multiply the x times 10, I will get 10x. If I multiply this times 10, here's a little math trick for you. If you multiply by 10 or 10 to the first power, you move the decimal over one place. You're making it larger by 1. It just shifts over. But please remember that when you move that over, there is still 7 and a 7 and a 7 and a 7 and a 7 because that is a repeating 7. Now, since we've done that, we've multiplied it by 1. Remember, this 7 could possibly still be repeating, and that's okay. Now, the next step is to move your original formula. You're going to subtract your original formula from what you just created, the equation you just created. So we're going to take away an x from this side, and on this side, we're going to take away the 0.7 repeating. So we are subtracting the original equation from the equation that we multiplied by the first power of 10. 10x minus 1x is 9x. And 7.7 repeating minus 0.7 repeating is just 7. And if you remember from 6th grade, maybe even 5th grade, and last year, how do you get the x all by itself? Well, this is multiplication. So you do the opposite to both sides of the equation. You divide both sides by 9. If you divide this side by 9, then it just leaves you with 1x. And if you divide this side by 9, we are left with the fraction 7/9. So this decimal, 0 and 7/10 repeating, simply turns into 7/9, where this decimal turned into 7/10. And this is what we need to practice and what we need to know by the end of topic 1. We'll continue topic 1 here in a few more minutes.